Hi guys, this is Mark from DynexHobby, and today I'm going to be talking about our latest analysis software. So I've gone ahead and downloaded the software from our webpage and installed it onto my desktop. So I'll go and double click on the icon to open the software. You'll notice on startup it has a new interface. We've gone ahead and listened to all the feedback from our customers online and incorporated all these fancy features, which will make the software a lot user friendly. So what you'll notice when you open the software are a number of buttons on the main page, and so you can actually analyze or balance according to the type of model you have. You also have a set of tools in the software that will help you locate the balance weight. There's also a measurement tool. Now the measurement tool is actually an advanced version of what we've had in the past. It also combines all the great features of the scope software and the vibe meter we've had all into one. So it makes it a lot more user friendly and easier to navigate. So what I'll do is I'll go through the features. I'll click on the aircraft. You'll notice another window appears, and the window has a number of buttons on the left hand side. So beside each button is a description of the method and what it's actually used for. So if I'll click on the first one, which is single plane, another window will appear, and this is actually the single plane method. The method actually has a tab box or series of tabs on the left hand side which you can navigate through. If I go to the introduction tab, it actually has the configuration that you need to apply for this method. So for the single plane, I need to use the accelerometer, the infrared sensor, and also the PC. So scrolling through each of these steps, so I've got step 1, there's a description at the top which tells you what you need to do for each step. So in this step I need to set up my rotor without any trial weights applied and run the device and measure the vibration and also the phase angle. Once I've done that, I can actually enter that into the text boxes. So proceeding through the steps, I just run through the method as described until you get to the answer tab. So when I actually put all the data in, I click on solve and actually gives me the balance solution. There are other features as well. There's a selection radio buttons for the units and also the spin direction of the rotor. So for the single plane balance, it's quite important that you get the direction correctly because that determines where your final balance solution appears. On the top right hand corner there is a text box for entering the target frequency or the speed you're running at. That's not really used by the analysis, but more as a reminder for you to recall what speed you're going to be running at. And just as a reminder, you need to run the same speed every time between each run. There's a phase calculator which I've included, and that allows you to manually calculate the phase angle, phase shift. That's mainly used for the old version of the scope software. The current version of this software, there's an automatic phase calculator, which I'll show you later. The next method is the two-blade. Two-blade method is quite simple. Again, there is a series of tabs on this window which describe the method. So for the two-blade, you only require the accelerometer and the PC. So running through the steps with this method, you basically run the rotor or the propeller in its current form without trial weights applied, measure the vibration and enter that into the text box. in the preceding steps, or the steps that follow, you apply a trial weight at the 0 degree position, run the propeller, measure the vibration, and enter into the text box. And so on and so forth. When you click on the Answer tab, you click on Solve, and that will give you the balance solution. So in this particular case, I have to apply my balance weight at the 180 degree position. There's a chart which illustrates vibration levels. Again, it's more for advanced users, just so that you can visualize what is actually happening in the solution. So that's the two-blade propeller method. The 4-point method, very similar to the two-blade method. Again, there's a description of what you need to set up for the method. So you have an accelerometer and the PC. The first step of the method again requires the user to run the rotor with no trial weights applied. So you measure the vibration and enter the value there. The preceding steps after that essentially requires you to apply a trial weight at the 0 degree position, run the rotor, measure the vibration, and enter into the text box. The steps after that require you to remove the trial weight at the 0 degree position, apply it at the 120, again run it, measure the vibration, and enter into the text box. And you continue through the tabs until you get to the Answer tab, and click Solve, and it will determine the balance solution on the graph. There is a modified tab included, and that's more for advanced users. Sometimes if you have excessive vibration or noise in the system, you can actually tweak the solution to give you the final balance solution. The next method I'm going to talk about is the clock method, and that's a very handy method used to fine-tune your balancing. So you could also use the method to balance, but also fine-tuning. Again, for this method, you only require the accelerometer and the PC. So the step requires you to measure the vibration by applying a trial weight at a number of locations around the clock face. So for the first location, it is 0 degrees. So I can apply the trial weight at the 0 degree position, run the rotor, measure the vibration, and enter into the first text box. The next position is at 45 degrees. Again, remove the trial weight from 0, enter it at 45, or apply it at 45, run the rotor, measure the vibration, and enter that value in the next text box. And so you remove the trial weight and move it around the clock face, and at each point you measure the vibration and enter into the text box. Once you've done that, click on the Answer tab, click on Solve, and that will locate the final balance solution. The next tab, or the last tab on the window, is a series of charts, and the charts basically map the vibration level around the clock face. So there's one chart which displays the vibration on a linear scale, and the chart below is essentially the same kind of plot. However, it plots it on a polar scale. And that's a very useful way of actually visualizing how bad the vibration is around the clock face. Now I'm going to talk about the tools that we have in the software. So if I click on the tool icon, you'll see I've got two main tools at the moment. The first one is the trial weight, and the second one the weight split. So let's click on the trial weight, and you'll notice a window appears which has a diagram illustrating the trial weight on the rotor. And what this tool does is, given the speed that you want to test at, the weight of the rotor, and the radial position of the trial weight, by clicking on the final box there, it would actually determine what your trial weight should be. So sometimes when you run a balance solution, you don't know where to start for trial weights. Well, this estimator will tell you the beginning point. There's a text box, or radio button, I should say, in the corner, which allows you to select your units from metric to imperial. The next tool I'm going to illustrate is the weight split. Now, the weight split's an excellent tool used to split your solution on a number of blades. Let's say, for example, you have a 3-bladed propeller and you've gone through the 4-point method or the single plane method and it determined the solution. The problem is the solution doesn't actually lie on the blade. Well, not to worry. What you can do is enter solution in the boxes down below where I'm actually highlighting. Enter your configuration above, so enter the number of blades, your disc diameter, and your balance solution. So if I click and solve, it will actually plot your propeller configuration, and the yellow crosses illustrate where to apply the final balance solution or your final balance weight. You can actually change the number of blades if you wish in your configuration, say from 3 to 5. Click on solve, and it actually replots and recalculates the balance solution. So in this case, I have to apply 2 weights at 0 degrees and 72 degrees, and also the weights that display down below. You can change the radial position, so instead of being closer to the tips, more towards the hub. So in this case, I'll make that 5, click solve, and you can see the solution is recalculated towards the hub. So that's a really handy tool to have. The last tool I'm going to talk about is the measurement tool, and that's the main tool that you normally use with the Vortex system. So if I click on that, a window will appear, and you have 2 options. We've got an advanced vibration meter at the top and a basic phase meter down below. So I'm going to click on the one above, which is the advanced vibration meter. And what you'll notice is there are a series of charts and dials and a lot of fancy things on there. So what I'm going to do is talk about what each chart is and what it does. The first chart illustrates the raw vibration signal, so you'll get the imbalance, and it also will show you noise in the system. It will also illustrate the IR sensor signal, which would be demonstrated as a pulse. Down below there's a frequency analysis tab or window, and what that does is it takes the raw signal and actually processes the signal and demonstrates or plots the frequencies that are contained within that signal. And that's actually quite handy to have. When you're running a balanced solution, you might have noise in the system that you want to filter out, and the frequency analysis will show you where the noise is occurring, and once you filter it, you can actually see the noise disappear in that window. There are a series of gauges. We have vibration gauge up the top, and also a digital readout of the gauge down below for easy viewing. Down below we have a speed gauge, which essentially measures your running speed in hertz. The speed gauge is actually quite an advanced gauge that we have. It actually doesn't require the infrared sensor like we've used in the past to determine speed. What it does, it has an advanced function where it calculates the speed from the main imbalance signal. That's really handy to have. On the right hand side we have a series of boxes, and it's mainly used for setting up the analysis or setting up the measurement tool. And I'll run through each one as we go. So what I'm going to do now is I'm going to simulate a noisy signal. So I'm going to turn the signal generator on. And so you'll notice straight away there is a noisy sine wave, and somewhere within that noisy sine wave is our imbalance signal. So I'm going to actually start setting up the filter. So before I do that, I'm just going to change this value to 2000. Okay, and immediately you start seeing the dials moving around. Change that to 0.1. Okay. So immediately what you'll notice on the chart below, the frequency analysis, there's two main peaks. Each of these peaks corresponds to a frequency. So the first peak, I'll just zoom up here, actually zoom up on the charts, click on play, it starts showing you the frequencies. So the first frequency is at 50 Hertz, the second one is at 500 Hertz. So what that's actually telling you is that your main vibration signal is at 50, but there's also noise which corresponds to 500 Hertz. That noise is actually not very good. You want to get rid of that noise, otherwise your balancing operation will be inaccurate, and it'd be quite frustrating to actually get the final solution. So what you want to do is you want to filter that that noise out. And what you can do is you can use our filter menu above. So you'll notice up the top right hand corner is two frequency values. There's a high frequency cutoff and a low frequency cutoff. What the high frequency cutoff does is it cuts off all frequencies above the value that you enter in that text box. The low frequency cutoff cuts all the frequencies below the value you have in that text box. So I want to isolate my imbalance signal, which is about 50 Hertz. So what I want to do, as a general rule of thumb, enter a value in the high frequency which is above, say 10 Hertz above 50, say 60. And a low frequency, say 10 Hertz below 50, which is 40. I've got 20, and that's okay. You'll notice immediately that the noise at 500 Hertz disappears or instantaneously, and you're only left with the imbalance signal, and that's great, and that's exactly what you need to do the balancing run. So below the high and low frequency text boxes above, there is something called a calibration factor, and what that allows you to do is essentially it's a scale factor. You can scale the gauge, so instead of reading say around there, you can scale it so it reads lower. So if I change it to 0.05, the dial will start dropping. So essentially what it does is scales the vibration value. The benefit of that calibration factor is you can actually calibrate the gauge to match other readings from other software if you wish. So it's a pretty handy tool to have. There's a maximum scale value. So what that does is it automatically adjusts the scale on your gauge. So instead of having say 1,000, you could have say 10,000, and you notice that your gauge will update automatically according to that scale factor. So I'll change it back to 1,000. Averaging is a very handy option to have. So if you have very noisy or if you have a signal which is giving you some difficulty in establishing a very stable value, you can actually increase the averaging values from default of 5 to say up to 50, and what you'll notice is that your dial will remain stationary at a value and it won't hunt or it won't jump around as much. So that's quite handy to have. The sample rate, again, that's just the sample rate from your audio device or your sound card. generally you want to select the value which is what your sound card is set at, but you can also change it if you wish. I've noticed that you can change it to lower or higher values and it'll still work just as fine. So the general procedure for setting up the analysis is you work from the top all the way down. Once you set those values, you can select your audio device. So if I click on channel 1, a new window will appear which lists your audio devices. So you can select one from the list, click OK, and you do the same thing for channel 2. Click OK. You notice that once you select the channels, the screen will freeze, and it's basically in a pause state because it's waiting for you to press start to continue the analysis once your new audio device has been selected. So I'll click on start now, and you can see that it starts recording. I've actually selected a higher sample rate, so that's why my sine wave appears a bit closer than what it did before. Other fancy tools we have is the pause button. You can actually pause the analysis, take the reading and put it into your single plane or 4-plane methods. So click on start again, that resumes the analysis. The last thing I want to talk about is the phase meter. So if I click on phase, a window will appear and you can select your audio device. And so what the phase meter does is it's essentially the vibration meter, the basic vibration meter, but it has the phase down below. So let me just demonstrate how that works. I'll turn that off and I'll turn my signal generator on. So with my new signal generation, I've got the imbalance signal and a pulse. And you can see that the phase meter is reading 0. If I increase the phase between the two, okay, you can start seeing phase values coming out. And there we go. So for the analysis, what you're really after is the value down below, which is the degrees. These values are just part of the basic vibration meter, not really required. These values are really superseded by the advanced meter. So you're only interested in the phase value down below. You will notice that sometimes it switches from a positive value to a negative value. That actually doesn't really matter. It's actually the same value that you're going to be seeing. So you can go clockwise to a point or counterclockwise. One's positive and one's negative. So that's a very brief overview of our software. I know you're going to find that be very useful for balancing and also vibration analysis. So go ahead, download it from our website. It's only available to customers of the Vortex system. But if you wish to purchase the software separately, you may. But anyway, that's the software in a nutshell, and I hope you enjoy it. Thank you.